3.3, proving lines parallel. Okay, if you remember back in 3.2 that we said if lines are parallel, if two parallel lines are cut by a transversal, then our special angle pairs had special properties. They were either congruent, alternate interior, alternate exterior, and corresponding angles were congruent, and same side interior angles were supplementary. Well, this is going to be the converse of 3.2. And if you remember, a converse is where we switch the if and then statements. So our converse here is going to say if we have special angle pairs that are congruent or supplementary, then our lines are going to be parallel. So in lesson 3.3, our objective is to determine whether two lines are parallel. And 3.2 is a little bit long, a lot of information there. This one should be shorter because it is the exact same lesson, only the converse of that lesson. So we are going to use the congruent and supplementary relationships of our special angle pairs to prove that lines are parallel, and our congruent angles were corresponding, alternate interior, and alternate exterior angles, and our supplementary angles were same side interior. So let's look at our first theorem. It's the converse of the corresponding angles postulate, so we can shorten this one down to converse of corresponding angles postulate. And it says that if two lines and a transversal form corresponding angles that are congruent, so we still have our two lines and our transversal, and our corresponding angles are congruent, that's our requirement, then we can say that our lines are parallel. So we see that we have two lines here, and we're going to mark our transversal. I like the transversal in green. And what we are given is that angle 2 is congruent to angle 6. So we are meeting our requirement that we have two lines cut by a transversal, and angle 2 and angle 6 are in corresponding positions and they are congruent. Then we can say that our lines are parallel. So line L is parallel to line M. Notice it's not marked parallel to start with. We are given two lines cut by a transversal. Our corresponding angles are congruent. Now we can say our lines are parallel. So let's look at our example problem. It says, which lines are parallel if angle 1 is congruent to angle 2? So I'm going to mark angle 1 congruent and angle 2 congruent. And now I'm going to identify my transversal. How do I find the transversal? Well, I know that my special angle pairs sit on the transversal. So line M has to be the transversal. Well, if M is my transversal and angle 1 and 2 are my corresponding angles, then my parallel lines have to be lines A and B. So lines A and B are parallel, and my reasoning is the converse of the corresponding angles postulate. So let's go ahead and pause the video and do the next problem. We were asked which lines are parallel if angle 6 is congruent to angle 7, and then to justify our answer, well, I marked angle 6 and angle 7 congruent, and then I know that my angles have to sit on my transversal, so I drew in my transversal, and then that let me draw in lines L and M which have to be my parallel lines. So L is parallel to M, and that is the converse of the corresponding angles postulate. It says if I have two lines cut by a transversal and corresponding angles are congruent, then I can say my lines are parallel. So you can see that this is just the converse of what we did last lesson. Last lesson, our lines were parallel. We could say our angles are congruent. This lesson, our angles are congruent. So we can say our lines are parallel. So let's look at our next few theorems here. I'm sure you can guess at what they are going to be. The next one is the converse of the alternate interior angles theorem. So converse of the AIA theorem. Okay, and it says if we have two lines cut by a transversal and alternate interior angles are, what did we know about them when they were parallel? Congruent. So if our alternate interior angles are congruent, then our lines are parallel. So let's look at what we are given. We have two lines cut by a transversal, and we told that angle 4 and angle 6 are congruent. So there is our transversal. That means that we can say we've met our requirements, that line L is parallel to line M. And our next one, converse of the same side interior angles theorem, converse of our SSI theorem, says, yes, if we have our two lines cut by a transversal and our same side interior angles are, what were they when the lines were parallel? Supplementary. If we have same side interior angles that are supplementary, then our lines are parallel. So we look at what we are given here. We are given angle 3 and angle 6. So they sit on our transversal here, and we are told that the measures of these angles sum to 180 degrees, which is the definition of supplementary. So I have same side interior angles that are supplementary, therefore line L is parallel to line M. And our last one, of course, here is the converse of the alternate exterior angle theorem, converse of AEA theorem. And it says, yes, if we have two lines cut by a transversal and our alternate exterior angles are, what was it from last time? That's it, congruent. If our alternate exterior angles are congruent, then our lines are parallel. You're seeing a pattern here. So we are given two lines cut by a transversal, and we are told that angle 1 is congruent to angle 7. Are they alternate exterior angles? Yes, they are. Opposite sides of the transversal outside of our two lines. Then we are allowed to say that our lines are parallel. Okay, so I'm sure you can see the pattern that we're following here. All of these are simply the converse of the theorems that we learned in lesson 3.2. So it's not really anything new. We are just switching up our order. Instead of saying that our special angle pairs have special properties, we are now saying that our lines are parallel. So let's look at some examples here. So far we have done the paragraph proof and the two-column proof. Now we are going to introduce a flow proof. And a flow proof, you've probably seen flow charts in all kinds of classes, English class, if you take computer class. It uses arrows to show logical connections between your statements, and your reasons are just written below the statements. So let's take a look at the proof of the converse of the alternate interior angles theorem. So we are given that angle 4 is congruent to angle 6. So we're going to mark them congruent. And I see two lines here cut by a transversal, and I know that my transversal has to have the angles on it. The angles have to lie on the transversal. So let's look and see what else we have here. Well, I see angle 4 and angle 2 are vertical angles. And I also see that angle 2 and angle 6 are corresponding angles. So how should we approach this? Oh, and check it out. I have matching parts there, so that's going to look like a transitive property. So I have done my define, explore. Okay. Our first step is always our given. Angle 4 is congruent to angle 6. That is given to us. And then what am I going to use? Well, I want 4 and 2 and 2 and 6. I want those to be together so I can combine my 2's. So how do I do that? Well, I use my vertical angles theorem. You can either write it out or use its name to say that angle 2 is congruent to angle 4. Those are things that we already know. And then we have angle 4 and angle 4, and we can use our transitive property of congruence to say that angle 2 is congruent to angle 6. So these two together lead to this step. And that is what a flow proof does, is you combine all of the steps that you're using together to get to another step in one column here. And I approve of the flow proofs because it can make it easier for you to see what you're putting together to get to that next step. And so then the final step says angle 2 and angle 6 are corresponding angles, and if they are congruent, then we can say that our lines are parallel. This is you can write it out, or you can just say converse of the corresponding angles postulate. Right, so again, a nice short proof. Let's look at another example. This is the proof of the alternate exterior angle theorem. We are given that angle 1 is congruent to angle 7. There they are. And I see two lines that are cut by a transversal, so I'm going to mark my transversal. And what else do we see here? You know what? I know that 1 and 3 are vertical angles, and 5 and 7 are vertical angles. And what else do you see? 1 and 5 are corresponding angles. Oops. And 3 and 7 are corresponding angles. And if you look at these, look at what we have. I see some combinations here that are going to, I gotta quit moving that are going to let us combine these using our transitive property. Right? So we have acknowledged our vertical angles, our corresponding angles, and we use our converse of the corresponding angles postulate to prove that lines are parallel. So let's see what this looks like as a proof. We start out, of course, with our given. And now I have angle 1 is congruent to angle 7. Well, I need something that works with either angle 1 or angle 7. And it doesn't matter which. So I could choose either one of these up here. This is our vertical angles theorem. It doesn't matter which one we choose. They decided to go with angle 3 is congruent to angle 1. And we notice here, that looks like transitive. We could have gone with 5 and 7, right? And then we'd have 1 and 5 and still have corresponding angles. Both of these lead us to using the transitive property of congruence, right? And then once we have angle 3 and angle 7, we just use our converse of the corresponding angles postulate, because now we have corresponding angles, to say that those are congruent. So as we said, what happened? I used purple. We also could have used angle 5 is congruent to angle 7, which would then have let us say that angle 1 is congruent to angle 5, and those are still corresponding angles, and we would have ended up in the same place. So it doesn't matter which one you use. All right, the next problem says use the same diagram and given information to prove that angle 3 is congruent to angle 5. So I am going to help you get started here. And the first thing you need to do is to redraw your diagram. And what are we given from up above? We are given that angle 1 is congruent to angle 7. So 1, 3, 7. So let's redraw our diagram. What do we have? 1, 3, 5, 6, and 7. Let's put arrows on everybody. And we are given that angle 1 is congruent to angle 7. How are we going to prove that angle 3 is congruent to angle 5? Well, let's look at what we have. I guess I'm not going to make you do this one all by yourself. Proofs are a little bit of a challenge, so we'll work through these together. Well, what do we see? Do you see 1 and 3 and 5 and 7 are vertical angles? We're trying to get 3 and 5. We're trying to get those alternate interior angles. And what else do we have? Well, take a look here. We've got 1 and 5, and 3 and 7 are corresponding angles. So hopefully you can see here. Ay, ay, ay. I don't know what I did there. Wasn't what I wanted to do. I see some transitive property going on. So let's turn this into a proof. Step 1 is going to be that angle 1 is congruent to angle 7. That, of course, is just our given. Oh, it said to use a flow proof. We're supposed to use a flow proof. Okay, let's try this. So angle 1 is congruent to angle 7, and that's just given. So we want something that we can relate to angle 1 and angle 7, or angle 7. We're trying to get to 3 and 5. Well, what can we combine here? What choices do we have? It doesn't matter We could either use 1 and 3 or 5 and 7. Doesn't matter. I am just going to go with angle 1 is congruent. Oh, I have a congruent sign up there. Angle 1 is congruent to angle 3. And that's just the vertical angle theorem. Okay, so there's that one. And then what am I going to do with these two? That's right. You see that? Okay, so I am going to use these two to take me to angle 3 is congruent to angle 7, and that's our transitive property of congruence that lets us do that. All right, so I've got to 3 and 7, and so now what's the next thing I'm going to use? What do I still need? I need an angle 5. Well, do I have something that relates angle 5 to angle 7? I sure do. We have an angle 5 is congruent to angle 7 by vertical angle theorem. Okay, and what do you see here? I see a 7 and a 7. So what are we going to do with that? Well, once again, we can use our transitive property to say angle 3 is congruent to angle 5 by the transitive property of congruence. So do you see how a flow proof lets you group your ideas together into columns and say, well, if I have this, then I need this to get me to my next step. And is there something I can put with that next step to get to where I need to go? So what happened with this one, we didn't need our corresponding angles at all. So very nice. That wasn't too bad. I do approve of using flow proofs. For some of you, this might be a good visual way to put the ideas together. All right, let's move on to the last page here. These postulates and theorems, or this postulate and 3 theorems, provide ways to determine if lines are parallel. Okay, so we are given a problem here where we have a fence gate is made up of pieces of wood in various directions. And we are told that angle 1 is congruent to angle 2. So first thing I'm going to do is I am going to redraw line R, line S, and we have a transversal, and we have angles 1, 2, and 3. That's an interesting direction to number them. And we are told that angle 1 is congruent to angle 2. And we want to know if lines R and S are parallel. So I look at these, and what do I automatically see? I see alternate exterior angles. And I have 2 lines cut by a transversal. My alternate exterior angles are congruent. So yes, my lines are parallel. 1 and 2 are alternate exterior angles, and they are congruent. And so by the converse of the alternate exterior angles theorem, I can say that line R is parallel to S. So we can even write in converse there. All right. Go ahead and pause the video and see if you can do problem 3. Okay, hopefully you saw that this is just a flashback to the proofs that we did on the front page that angle 2, we are given that angle 1 and angle 2 are congruent. Angle 2 and angle 3 are congruent by the vertical angle theorem. So I can make this one congruent. And then I can see that angle 1 and angle 3 are congruent by our transitive property here. Right? Those two are going to cancel each other out by my transitive property of congruence. And then angle 1 and angle 3 here are corresponding angles. Right? We know those are corresponding angles. And I can say that line R is parallel to line S by the converse of the corresponding angles postulate. So we can, this is just the proof of the alternate exterior angle theorem that we already did. All right, hopefully you are starting to see these proofs come together. You are starting to see the relationships between our definitions and postulates and theorems. Pardon me. Now, what else does this let us do? Our final thing here is we can solve problems involving parallel lines. So this is harkens back to lesson 3.2. It says, what is the value of x if A is parallel to B? So we are going to say that these lines are parallel. So we have to look at our angles. What kind of angles do we have here? I see same side interior angles, and what do we know about same side interior angles? They are supplementary. So we can just substitute in, actually the measure of angle 1 plus the measure of angle 2 equals 180 would be the definition of supplementary. And then this here would be our substitution property. And then simplifying, subtraction property of equality, and division property of equality. And that's how we do that. So go ahead, pause the video, do the last problem. All right. So we were told that C is parallel to D, and then you should have noticed that you have corresponding angles. We know corresponding angles are congruent. So I marked them as angle 1 and angle 2 so I could identify them. I said angle 1 is congruent to angle 2 by my corresponding angles postulate, and then I set the measures equal by the definition of congruence. Remember that these two steps here frequently go together. And then I substituted in my numbers, added 2 to both sides, addition property of equality, divided by 3 on both sides, division property of equality, and then I had 19 equals W, and the symmetric property of equality lets me say W equals 19, lets me switch sides. So I was asked to find W, and W equals 19, and I went over here and I checked it, and I substituted in 19 for W, and by golly, I got 55. So my corresponding angles are congruent. Okay, this lesson is just a reverse repeat of the last lesson. In lesson 3.2, we said if we have parallel lines, then special angle pairs have special properties. They are congruent or supplementary. In this lesson, we did the converse, so we switch our if and then statements. So if our special angle pairs had special properties, either congruent or supplementary, then we could say that our lines are parallel. So this is just the same thing, only backwards. So enjoy, have fun with the homework. Again, these are some of my favorite postulates and theorems in geometry. I hope you enjoy them as well.